So today we're going to take a look at surface areas. And I guess the first question that you might ask is, why would I be interested in being able to calculate the area of a surface? Well, I mean, maybe you have a surface like one of those computers and you want to find out what is the area that you can write on. So you could find the surface area of a surface. But more realistically, anytime you want to, let's say, paint the wall in a house or paint a room, you want to find out what the surface area of that room is so that you know how much paint you have to buy to cover that surface. If you're trying to make a container to hold a certain volume, then that cardboard on the outside, that's your surface area. Or the metal that's on a can, that's your surface area also. And as a manufacturer, you might be interested in how can I make a container that holds a certain amount of material but costs the least amount of money, right? It would be more environmentally friendly for one thing, but it would also cost you less as a manufacturer, would cost you less to ship if you could minimize the amount of surface that you had but still held the same amount of volume. So for each of these, we're going to take a look at the different formulas. We'll try a couple of problems, and then at the end we will take a look at a summary table, hopefully, that can help us to organize all of this. So these were the questions that I had just sort of put out as leading introductory questions. Why would you want to find the surface area? What could you do if you knew the surface area? And we already talked about that a little bit. So there's two types of surface area. Lateral surface area just goes around the outside. We call those things the lateral faces. So if you have one of those, let's say a pentagonal prism, the rectangles on the outside, that's your lateral surface. Then if you add in the two pentagonal bases, top and bottom, now you've got the surface area. Sometimes I'll also call that the total surface area because that includes both the base and the top and the bottom. Sometimes you're not interested in the total surface area. Sometimes part of the surface area will do. So for example, if you were trying to paint the outside of a barn or something that was sitting on the ground, you wouldn't pick the object up and paint underneath it, so you wouldn't need the area of the base on the bottom. So sometimes you're not looking for the entire surface area. Best way to do this is to look at the nets and see what the shapes of their faces are. So the cube is the easy one because every side in the cube is exactly the same. So the book uses an E for the edge. I like S's because E is actually a number in higher level mathematics. So if the side of my cube is S, and this side is S, it turns out that every face is an S by S face. So the area of this face is side squared, and the area of that face is side squared, and so forth. So the lateral area of a cube is just the four faces, right? Just these four faces that are side squared and side squared. So 4 times the side squared is your lateral surface area. Your total surface area, right, is going to be all 6 of them. So if you had a cube with a side of, let's say, 4, okay, a cube with a side of 4, the lateral area would be 4 times 4 squared. So 16 times 4, that's 64. And if we measure this in inches, then the lateral area would be measured in square inches, right? These are areas that cover a surface, so they're measured in square units. The total surface area then would be 6 of them. So 6 that are each 4 squared would be 6 times 16, which is 96. And again, square inches, because you're measuring an area. Area is measured in square units. So the cube is the easy one. All 6 faces are the same. If you want the lateral surface area, include 4 of them. If you want the total surface area, include all 6 of them. All right, how about this guy over here? If I move this up a little bit, this is a pentagonal prism. All right, so the pentagonal prism has a pentagon for a base, and it's got 1, 2, 3, 4, 5 rectangular faces. Now, the lateral area is just going to be the sum of these 5 rectangles, right? Rectangle over here, rectangle here, 3, 4, 5. So if I add up those 5 rectangles, I will have found the lateral surface area for my pentagonal prism. So maybe I'm constructing the lateral area with something different from the base on the top and the bottom. Maybe I'm just painting the outside of the object and I don't need to paint the ceiling and the floor. So if I want the lateral surface area, then I just want those 5 rectangles. Now, how do I find those 5 rectangles? Well, if you notice over here, that's the height of the prism. That height is the same thing as this height over here, and it carries on this side as well. So if you look at, let's just say this first rectangle here, this first rectangle here has part of the base, part of the perimeter as its base, and then this side over here is its height. So if you wanted to find the lateral area, just that rectangle, you would say it's side 1 times the height. But then as you walk around, you're going to take side 1 times the height, plus side 2 times the height, plus side 3, plus side 4, plus side 5. You'll have included all 5 sides times the height. Well, rather than calculate those 5 things separately, what happens when we take side 1 and side 2 and side 3 and side 4 and side 5 and add them all together? Really what we're doing is we're taking the perimeter of the base. So oftentimes in the formulas, you'll see that P represents the perimeter of the base. And we use a lowercase p because it's a linear measure. So if P is the perimeter of the base, and then H is the height of the object, we can represent the lateral area of this prism as the perimeter of the base times the height. Meaning that rather than calculate each of those 5 rectangles separately, why not just realize that those 5 sides add up to the perimeter, multiply the perimeter of the base times the height. Now, why is that helpful? Because what if I added another face to this? What if I made it a right hexagonal prism? Or added 8 sides altogether and had an octagonal prism? You realize the formula for those are exactly the same as the formula for a pentagonal prism. So rather than marry myself to just those 5 sides, a more general formula for the lateral area of a prism in general is perimeter of the base times height. Now, if I want the total surface area, right, the total area or the surface area, that would include the lateral area plus the area of the 2 bases. Now, this one is a prism, so a prism has 2 bases, right? One down the bottom over here, one on the top over there. So you've got to find the area of those 2 bases. Sometimes you'll see it written like this also, right? The surface area or the total area is going to be the lateral area, which is perimeter of the base times height, plus 2 times the area of the base. Now, I'm being a little bit general in this variable over here in that rather than come up with a separate formula for every prism, if I leave it like that in general, then I can just adapt it to whatever type of prism I have. So if I had a rectangular prism, the area of the base is length times width. If I had something like this, if it were a regular pentagonal prism, then I could use 1/2 apothem times perimeter of the base to figure out what the area of that base is. So I'm going to leave that as just the capital B. And then what you're going to find is that when you come around and do cylinders, same type of formula holds. So the formula down the bottom says surface area is perimeter of the base times the height plus twice the area of the base. And there it is. Just be careful, difference of bases, right? That capital B, we use capital letters for area. We use lowercase for length. So if you're adding the sides of the base together, those are lower cases because they're the length. If you find the area, that's an uppercase. All right, so here's a prism. This is a triangular prism. We name these types of prisms by the shape of their base. So this thing down here is the base. Now, it happens to be sitting on the base. But if I had turned this triangular prism sideways, it would still be a triangular prism because there's 2 triangles that are in parallel planes, right? The other one is up here. And then the other faces are all rectangles. So just because you flip it on its side doesn't make it a rectangular prism. It's still a triangular prism. So let's find both lateral area and total surface area. So lateral area is perimeter of the base times the height. Well, the perimeter of the base is found by adding the 3 sides, 3 and 4 and 5. So the lateral area is the perimeter of the base, 3 plus 4 plus 5, times the height of the whole prism, which is 10. So 3 plus 4 is 7, plus 5 is 12. So I get 12 times 10. Lateral area is 120 square centimeters. Now, that lateral area is just the sum of the rectangular faces. Doesn't include the triangles top and bottom. So if I wanted the sum of those 3 rectangular faces, it's 120 square centimeters. Could I do them separately and add them together? Sure, I could, right? The height is 10, so I could do 4 times 10 plus 3 times 10, right? Those are the 2 faces in the back. And then the one in the front is 5 times 10, and I could add 40 plus 30 plus 50 and still get 120. So you could introduce the problem that way, but then eventually you're going to want a more efficient way to solve it. All right, so suppose I wanted the total surface area, meaning that I also want to include the triangular bases. All right, so in that case, I need the area of the base. Well, the area of the base is a triangle, so 1/2 base times height, and this is what I mentioned before. Be careful of the difference in bases. This base over here, the capital B, is the area. The lowercase is just the length of the base. So the triangle looks like this, right? It's a right triangle. It's 3, 4, and 5. Notice that I've got a 3 and a 4 that are perpendicular to each other. So right there is my base and my height. If it wasn't that neat, you would have to try to find the altitude. And it may be a matter of 30, 60, and 90 triangles. It may be a matter of playing around with the different areas to figure out what that missing piece is. So 1/2 times the base, which is 4, times the height, which is 3. Half of 4 is 2. 2 times 3 is 6. So the area of my base is 6. All right, so now it looks like I'm ready to throw the whole thing together. So the total surface area is the lateral area, which is 120, plus twice the area of the base. All right, because I got two bases. I got a base of 6 square centimeters up there, down there, and I got a base of 6 square centimeters up there. All right, so I got 120 plus 12, so my total surface area is 132 square centimeters. So these things are still measured in square units. That's how I find the total surface area of my prism. All right, same process applies if you had prisms of other dimensions. All right, so suppose I take this right prism. I started with a rectangular prism, but then I decided to add some more sides. All right, so the next one looks like it's an octagonal prism, and then I add more sides and more sides. You realize if you keep adding more sides, eventually this becomes circular. And so a prism and a cylinder are very much related to each other, right? They both have bases in parallel planes. This prism has bases up here on the top and down there on the bottom. This cylinder has bases up here on the top and down there on the bottom, except in a cylinder, instead of having the sides as line segments, I have a measure in the center here of a radius. All right, so now if I want to find information about my cylinder, that cylinder can be calculated in almost the exact same way as the prism. If I know the area of the base and I know the height, then I can figure out what is the surface area. The surface area of the cylinder, the lateral surface area, would just be this piece over here. In other words, it's the label around your soup can. The total surface area would include the lids. All right, so if you were manufacturing a can and you had different materials for the outside of the can versus the top and bottom, the lateral surface area would be the outside. The total surface area would include both bases. All right, how do we calculate it? I'm showing you this formula because I think this is the one in the textbook. It's not my favorite formula. I will show you one that I think is easier. If you want to find out the total or the lateral surface area here, so lateral surface area, let's think of the label of the can. That's what? That's this thing here. 2 pi RH. Well, 2 pi r is the circumference of the circle. That is the base. Isn't circumference the same as the perimeter of the base? Well, sure it is. Right? The circumference is this piece that walks all the way around your base. I picked the top base. You could pick the bottom base. If you had a subwoofer, that would give you even more base. So look, there's the perimeter of my base. So rather than using 2 pi r, why don't I just write perimeter of the base? And then the height, that's just there. So the lateral area, instead of 2 pi RH, how about the perimeter of the base times the height? And that's the same formula we had for the prisms about 2 minutes ago. So rather than memorize a new formula, remember perimeter of the base times the height, and then you can substitute from there. If you want the total area, the total surface area is going to be your lateral area plus the area of two bases. So I can think of the total surface area of a cylinder as the lateral area, right, perimeter of the base times height, plus 2 times the area of the base. Well, all right, if I want to substitute for the area of the base, I can substitute pi r squared because I know it's a circle, and that's how they got this formula up here, right? This is twice the area of the base. That's the lateral area. If I remember my lateral area is perimeter of the base times height, then I don't have to keep going back and trying to remember another formula for every type of object. All right, I'm going to break this apart and we'll do a second video with the surface areas of pyramids and such.